Hello, everyone. It is I, Mr. E, here for part two of the Geometry Midterm Review. Let's get right to it. I'd say something funny, but I don't know anything funny right now. Okay, what is the point of concurrency for the following special segments of a triangle? The perpendicular bisectors. Oh, goodness. Come on, man. All right, what's the point of concurrency? The following special segments of a triangle. Well, remember this? An odd peanut butter cup may contain apple butter instead. So, an odd altitudes, orthocenter, ortho centre. That's French. I don't need to change colors. The perpendicular bisectors, that's the peanut butter cup. Circumcenter. Angle bisectors, that's the apple butter instead. So that is the in center. And that means the medians, that leaves the centroid. All right. Let's see. In triangle, yes, we can skip this one because it's a reflection. It's translations. In triangle ABC, G is the centroid, and BE, here's the centroid, and BE is 24. BE, all of this is 24. Find BG, and here's BG, and GE, which is this piece right here. Well, the centroid, remember that? The centroid goes from the, I'm just drawing it kind of out here, goes from the vertex to the midpoint. And remember, the bottom half's not a half. The bottom piece is 1/3, and the top piece is 2/3. So, of the entire length, that is. So, let's just erase all that. So, BE is 24. So, let's divide 24 by 3. That gives you 8. So, this is 8, and this is 16. It looks like an 8. So, that's 16. So BG equals 8 and GE equals 16. There we go. All right, where do the following points of a triangle fall? Oh, boy. Okay, the orthocenter for an acute triangle. Oh, boy. Let's see. That falls inside the triangle. The right triangle, the orthocenter for a right triangle was on the, I gotta write all this, on the vertex of the right angle. And then obtuse was outside. Okay, the in-center, well, these are always inside. Because it's equidistant from the sides of the triangle. And you can, whatever triangle you draw, it's going to be on the inside, so it has to be inside. The in-center is the center of the inscribed circle. Okay, circumcenter. Well, that one is always, no, not always inside. Let's see, for an acute, it's inside. And for an obtuse, it's outside. And remember, on the for the right angle, this one is on the hypotenuse. All right, the centroid always inside because it's also the center of gravity, if you remember that. So it's going to be inside the triangle. All right. What we got here? We got some midpoints. Given that B and C are the midpoints of XZ and YZ, respectively, so B and C, it's a midpoint. And YZ, this is a midpoint. And of course, I'm sure this is as well. Has to be. XY, this distance here is 6x minus 11. And BC is 2x plus 3.5. Ugh. Why? Okay. Well, here is the third side of the triangle to this mid segment. So 2 of this one equals 1 of that one. So 2 times 2x plus 3.5 equals 6x minus 11. So let's distribute. We got 4x plus 7 equals 6x minus 11. Let's subtract 4x from both sides and add 11. So 18 equals 2x, so x is 9. X is 9, and we want to find BC. So BC is 2x plus 3, so 18 plus 3.5. That's 21.5. There we go. Alrighty, next find the indicated angle measures, please. Let's draw on what we're given here. Let's see. CA is parallel to AB. Not parallel, perpendicular. This is a right angle. CA parallel to DB. And then the measure angle 1 is 42. Measure angle 8 is 72. 72. All right. Well, let's see. Let's start with the easy part. Here's an angle that's 42. Here's an angle that's 90 degrees. So this angle down here, which is the third angle of this big triangle, needs to be, what is that? 180 minus 90 minus 42 is 48. That's the measure angle 4. 48. All right. Can we do this? What else can we do? Let's write these in as we go. 48. Let's use these parallel lines. 1 has to be the same as 7, right? Those would be corresponding angles. So 7, not corresponding, alternate interior, which are congruent. So 7 is 42. And if that's 42, then, you know what? This has to be 90 degrees too. Sorry, I'm skipping ahead. But if that's 42, it's 48 equals 90, then this one has to be whatever 180 minus 42 minus 72 equals 66. So that's 10, that's 66 degrees. This is 66. Which means that 6 is 66 as well. Looky there, yes, I see it. And then a linear pair, let's see, 180 minus 66 is a 114. So 5 is 114. What do we have left here? Let's see, 2 and 3. What are those angles? Well, let's see. Here's a triangle. 180 minus 42 minus 66 is 72. So this part is 72. Let's say 72 from 90 is 18. There we go. That wasn't so hard. Ooh, we're on to the next page. Oh, and this is the last page. Oh, okay. Did we do more already? Seems really fast. Sure did. Okay. Draw the medians for the central. Draw the medians for the following triangle and give the coordinates for the centroid. All right. Draw the medians. Well, we need to find the midpoints. So let's see. The midpoint. We go down 2 and over 1, 2, 3 for that segment. So let's go down 2 over 1.5. And then we'll go up 1, 2, and over 1, 2, 3, 4, 5, 6. So let's go up 1 and over 1, 2, 3. And then this one we go up 1, 2, 3, 4, and over 1, 2, 3. So let's go up 1, 2, and over 1.5. And there it is. And if we draw in the medians, let's see, here's one median. There's another median. And there's the third. So there's our centroid right there. At, oh, this is so bad. I guess is this the origin? Yeah. So 1, 2, 1. So the centroid, we'll call it C. No, it's already a C. Centroid is at 1, 2. All right. Yeah, we don't have to do that because it's trig. That was trig too. All right, triangle ABC. Its size lengths 7. Let's draw it out. A, B, C. AB is 7, BC is 14, and AC is 8. Order the angle measures from least to greatest. Well, remember, the largest angle is across the longest side, so A is the biggest, and that would make C the smallest. So B is in the middle. Least to greatest. There we go. C is less than B, which is less than A. All right. Is this the last one? It sure is. Look, we get to graph, so we're going to color. Yay. All right. Triangle ABC has vertices at A, -2, 6. -2, 6. Here's A. -2, 6. B is at -2, -4. And then C is at -4, 6. Right there, that's C. Find the coordinate for the following points. Wow, this is a horrible. Why make the triangle so small? All right, we want to find the coordinates for the orthocenter and the circumcenter. Well, let's see, the orthocenter comes from the. We just have this question. The orthocenter. Maybe it was on the other one. Where did it go? Oh, there it is. The orthocenter comes from the altitudes. So we're going to draw on the altitudes. The circumcenter comes from the perpendicular bisectors. Okay, so the altitudes are perpendicular to a side and go through the vertex. So, and this is the right triangle. So, oh, you know what? Let's look back here. Where do the following points of the triangle fall? The orthocenter of a right triangle is on the vertex of the right angle. So, it's right there. -2, 6. And then the circumcenter, well, let's see. The circumcenter is on the hypotenuse. The right triangle. So it's going to be on the hypotenuse, and it's going to come from the perpendicular bisector. So check this out. Zoom in. Perpendicular bisector. Well, we're going to bisect this. That's obviously the midpoint. There's perpendicular bisector. And then let's see, from 6 to -4, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5. There's a midpoint there. And then the other midpoint would be like, oh, well, we can see. Let's see. It's 1 over. And what was that from? I just draw this coordinate. Yeah, I think I just drew this really bad. So it's going to be right there. Yeah, I just draw this very well. Okay, so it's going to be right there, which is minus 3, 2. Minus 3, 2. Minus 3, 2. There we go. All right. Minus 3, 2. Yeah, you can draw on that other one, but it's going to be right there. It's going to go that way. Okay, I think we're done with this review. All right. I hope you enjoyed it as much as I did.